Hello everyone, and welcome back to Coding with Lying, my sort of video documentary of how I'm going about making my final year project for university. New visitors will want to look at the earlier videos because I explain a bit more detail exactly what this is all meant to do, and if you're not familiar with coding in JavaScript and Java and all similar kind of languages, this might be a little bit difficult for you to grasp, but I'll try and be as explanatory as I can. So, this code is the first neural task, that is to say the first task item inside of the AI system which uses a neural network, the aim of which is to create a task that is more flexible than the usual boolean. And to that end, we have last episode's neural network code here. I've cleaned it up a bit, and I still need to figure out the activation piece here, but other than that, this is more or less functional. We've got our end data, our neural network data, so there's all of the different details divided by the appropriate pieces, which are then split apart to retrieve them. And these are just junk weight values, so don't really worry about them. Though the link data is accurate for this particular system. This particular system is for the neurovillager, and this is currently his only task, and it hasn't yet been fully compiled, but I'll explain what's happening anyways. So this is basically replacing entity AI avoid entity, which makes the standard villager run away from zombies. What we want it to do is to have him run away from neuro zombies, and we want it to function entirely based on the neural network data. So our inputs are as such. We have the entity code, the entity ID of the creature that the villager is presently targeting, whether that should be another villager, an iron golem, a player, or a neuro zombie. And then we have the distance. Now I'm pretty sure there is actually just a basic Java code for this, but I just decided to put it here just for a little fun, more or less. So that gives us our initial inputs of what is the ID code for the creature we're looking at and how far away is it. So if that returns to be neuro zombie, and if this returns to be too close, flee. And that then just runs the actual code, which tells the navigator to start moving away from it. So, what I'm mostly working on at the moment is the activation function, but everything else here is pretty much set up. So we've got the bindings here, which are broken apart by the slashes of input ID and then weight value, which is used here and here, respectively. So everything boils up together. If you reverse that whole process, you get end data up here. So, for example, here is one layer. That is one layer with two different neurons in it. So one there and one there. We also have support for multiple neurons in a, well, multiple bindings in a single neuron. For example, right there, that's using two of them. And we have support for, of course, multiple neurons per layer and multiple bindings each node. So this can be as large as we like. This is presently just using 8 neurons. And the idea for the moment is that I need to figure out the weight values to create the, to replicate the Boolean conditions that we have down here. So here in the original code out of entity AI avoid, we have, is it an instance of the target class? So yeah, we can see that it's selecting all the entities nearby that are that class. We're only paying attention to the one that the villager is actually aware of, which will probably produce some differences in behavior, but that much can't really be avoided based on how we're actually implementing this. So we need a boolean. We need the boolean that is, does this initial input value match the value that we're looking for? And you can do that inside of neural networks. That's used quite often for recognition. So that shouldn't be too difficult. It's just a matter of getting the input values right and the different neural structures right. And then we have to do it as well for the actual distance. Again, this was used down here, so that produces all. That is used to determine minimum and maximum distance, which is part of the initial values for entity AI avoid entity. And we need to then construct another sort of sideline neural mini network, a sub-network, which determines whether the distance is above or below a certain value, most likely equal to or above. And that value will most likely be hard-coded, and we will then be able to, later on down the line, we can retrieve these end datas from the entity individual itself, so that every single neuro villager can have its own idea of how close is too close for a neuro zombie to be, as well as all manner of other entities. So, for example, we could have another one here for normal zombies, we could have one for players, we could have it for all manner of different entities that we want them to avoid. And it would just be simply a matter of creating a new instance of Neuro Entity Flea inside the creature and telling it which neural data to look at. And then that also means we can then... the next thing, once we've gotten this whole thing done, is to branch it out, repeat it, copy it around so that we can replicate a bunch of the different behaviors that the villagers go through, and then do the same for the Neuro Wolf, the Neuro Zombie, and the Neuro Skeleton, so that they are then able to closely, or if not identically, replicate the existing behaviors of their task-only counterparts. After that, we can then install the learning algorithm, which will allow them to change their behavior over time by altering what these weight values are and what these references are, potentially. I might just go with the just with changing the weight values so that they're only able to change so much of their behavior and the rest of it is actually still relevant to the gameplay that we're after. But a more complex system would allow them to add new neurons, get rid of neurons, and change which neurons are linked to what input values. And then we can also give them genetics so that their end data is based on the end data of their parent entities. So whenever a pair of neurovillagers breed, their offspring will have distinct and unique end data, give or take a bit of mutation so that they can change over time. And that will be largely it. So my work for the week at the moment is to get this one task working, which is, as I say, just down the activation function, and figuring out what the weight values should all be and how it should be arranged. And then I will be replicating this over to the Neurozombie and whatnot to make them actually all interact as they should. But this is a significant moment because this is the very first neural task that I have developed. So that is an important milestone inside the project. We have our first neural task. Creating ones after this is very easy because the groundwork is basically this chunk. But with that in mind, I shall catch you all next time.